Welcome back to Maths in an Empty Classroom with me, Mr. Summer. This is the second example of finding an area between a curve and a line using integration. This is the second type of scenario. So what we have here is we have a curve with equation y equals 8x minus 12 minus x squared, and we have a line with equation y equals 6 minus x, and we're being asked to find the area of the region R, which is between the line and the curve. So in the first example, I talked about the first thing we needed to do be to label any points of intersection, draw vertical lines straight down to the x-axis, and that tends to give us an idea of what we're trying to work with. So this point here, where the line and the curve intersect, is the point A, and this point here, where the line and the curve intersect, is on the x-axis, it's the point B. And as you can see, if I draw a vertical line straight down from the point A, you should begin to be able to see what it is that we're going to have to do here, because what I'm left with is a triangle. Now this one's a little bit different in that if I integrate between the x value at A and the x value at B, it's going to find me the whole area between the curve and the x-axis. So it's actually going to find me the red bit and the blue bit, the total. But I only want to be left with the red bit. So whereas in the previous one we had a shape and we had to take away the value of the integral, this one here we're going to be finding the value of the integral and we're going to be taking away the area of the triangle. So as with the previous one, we're going to start off by finding those 2 points of intersection, A and B, by solving the equation simultaneously. So we could say, right, 6 minus x equals 8x minus 12 minus x squared. And I'm going to add over the x squared, subtract the 8x, and add the 12 to make a quadratic, and I did it that way deliberately so that I end up with a positive x squared. The two solutions to this equation are x equals 3 and x equals 6. Now with the previous one we knew what y was because it was a horizontal line. This one here we are going to have to substitute back into one of the two equations to find the y coordinate. So pick the one that's more straightforward. So y equals 6 minus x. So y equals 6 minus 3, which is 3, which means that A is the point 3, 3. And then for the other point B, y equals 6 minus 6, which is 0. So B is the point 6, 0. And that should make you happy because that point is on the x-axis as we expected. So with maths questions, build in those little checkpoints as you go. Make sure your answer makes sense as you're working through it. I can see B is on the x-axis. I've got a point on the x-axis. Happy days, I'm doing it right. Let's carry on. So what I'm now going to do is I'm going to find the area of this triangle. So just a very quick sketch of it here. This point up here is the point 3, 3, which means that this is a length of 3. Along the base of it, we're going from 3 to 6, so this is also 3. So doing base times height divided by 2, 3 times 3 over 2, the area of that triangle is 9 over 2. So I'm going to put that up here. As part of the solution I'm going to be working with. Once I've found the value of the integral, I'm going to be taking away 9 over 2. I can also add in to my sketch the labels for those two coordinates, as I now know what they are. Now I'm going to be integrating between 3 and 6 to find this area here. The equation that I want to integrate is the equation of the original curve. Remember, don't look at this one, look at the original curve because that's the curve I'm trying to find the area between the curve and the x-axis. So I'm going to integrate that between 6 and 3, 8x minus 12 minus x squared with respect to x. that's going to integrate to 4x squared minus 12x minus 1/3 of x cubed, an upper limit of 6 and a lower limit of 3. So using square brackets at this point. Okay, so subbing in 6, we get 144 minus 72 minus 1/3 of 6 cubed, which is also 72, which is quite neat, so that comes out of 0, I quite like that. Sub in 3, we get 36, sub in 3, you get take away 36, and minus 1/3 of 3 cubes, that's minus 9. So what we've got here is we've got 0 subtract negative 9, which is 9. Now remember what we found here, that is the area of the red bit and the green bit combined, because it's the area between the curve and the x-axis, between those two x limits, so that's what that 9 represents. So if I put the 9 back up here, 9 minus 9 over 2, the shaded region R is 9 take away 9 over 2, which is 9 over 2. Which is quite neat, because that actually means that the green area and the red area are equal, even though it doesn't necessarily look like that from my diagram, but I think that's pretty cool. So second scenario that we sometimes meet is you've got a diagonal line and a quadratic curve, and you need to find the area through integration and then subtract the little triangle that you get underneath. I'll see you in the next part for the third type of scenario.